Welcome to Spaceverse, your portal to cosmic adventures. Imagine peering across 10 billion light-years of space and witnessing a cosmic catastrophe so powerful it outshines 10 trillion suns. That's exactly what astronomers have just done, spotting the biggest and most distant flare ever seen erupting around a black hole. At the heart of a galaxy so far away that its light began its journey when the universe was less than a third of its current age, a supermassive black hole is tearing a massive star apart. The galaxy is known as J2245+3743, and its central monster, a black hole 500 million times more massive than our Sun, is in the middle of one of the most extreme feeding frenzies ever recorded. To put it simply, this cosmic giant bit off more than it could chew. Astronomers using the Zwicky Transient Facility, or ZTF, were the first to detect this incredible event. ZTF is a sky survey project that constantly scans the heavens for anything that changes, brightening stars, exploding supernovas, or flares from distant galaxies. Back in 2018, they noticed something odd. The galaxy J2245+3743 began to brighten, and not just a little. Over a few months, it became 40 times brighter, turning into an absolutely dazzling beacon visible even across billions of light years. At its peak, the flare was 30 times brighter than any previously observed black hole flare, releasing as much energy as 10 trillion suns. Let that sink in for a moment. 10 trillion suns, all their light and heat combined, pouring out from a single point in space. It was soon clear that this flare wasn't just another case of a black hole feeding on nearby gas and dust. Something much more dramatic was unfolding. At the center of most galaxies lies a region known as an active galactic nucleus, or a GN, a place dominated by the activity of a supermassive black hole pulling in matter at incredible speeds. Around these black holes swirls an accretion disk, a flattened cloud of gas and dust heated to millions of degrees as it spirals inward. But this flare didn't come from the disk. Instead, it came from a star that strayed too close, a truly colossal one, about 30 times the mass of our Sun. The black hole's gravity, unimaginable in strength, ripped the star apart. Its outer layers were stretched, shredded, and drawn inward, forming a stream of gas that spiraled toward the black hole. This kind of cosmic event has a name: a tidal disruption event, or TDE. You can picture it like this. The star was peacefully orbiting near the galactic center until it wandered into the black hole's deadly zone, where tidal forces are so strong that one side of the star feels a much stronger gravitational pull than the other. It's torn apart, piece by piece, as if pulled like taffy by an invisible hand. As Matthew Graham from Caltech colorfully described, the star isn't completely gone yet. It's like a fish only halfway down the whale's gullet. Over time, the flare began to fade, but slowly indicating that the black hole is still consuming the remains of the doomed star. K.E. Sauvik-Ford from the City University of New York described the sheer energy involved in striking terms. If you were to convert our entire Sun into energy using Einstein's equation, E=mc², that's how much energy has been pouring out from this flare since observations began. In other words, every second of this event's life has been unimaginably powerful. And yet, because the black hole lies so far away, the light we see from this event started its journey 10 billion years ago, long before the Earth, the Sun, or even our solar system existed. We're not watching this happen now, we are watching it in cosmic replay. Even more fascinating is the role that time dilation plays here. Near a black hole, gravity warps space and time itself. Time actually runs slower in regions with intense gravity, a prediction of Einstein's general theory of relativity that's been proven again and again. Matthew Graham explained it this way: 7 years here is 2 years there. We are watching the event play back at quarter speed. So as the black hole continues to devour its unlucky prey, we get to observe it unfolding in slow motion, stretched out not by human technology, but by the very fabric of the universe itself. This stretching of light and time, called cosmological time dilation, happens because the universe is expanding. As light travels across space, its wavelength stretches, and so does the apparent passage of time. That's why long-term observatories like the Zwicky Transient Facility are so vital. They can track slow, evolving phenomena like this over years or even decades, revealing the full story of cosmic events that play out on timescales far beyond human lifetimes. Now, tidal disruption events themselves aren't new. Astronomers have identified around 100 TDEs so far. But here's what makes this one unique. Most of them don't occur in active galaxies, that is, galaxies whose central black holes are already feeding and emitting light. In active galaxies, the existing light and energy from the accretion disk can hide other bright events like TDEs. It's like trying to spot a flashlight beam in front of a raging bonfire. But in this case, the black hole's enormous size and the sheer brightness of the flare made it stand out, even from 10 billion light-years away. Initially, though, astronomers didn't realize how special it was. They continued to observe it for 5 years, and it wasn't until 2023 that data from the WM Observatory in Hawaii revealed the true scale of its energy output. Once the numbers came in, it became clear this was no ordinary black hole flare. But scientists had to be careful. There were 2 alternative possibilities they needed to rule out. First, they considered whether the flare was beamed, meaning its energy might have been directed straight toward Earth, making it seem brighter than it actually was. Using data from NASA's now-retired Wide-Field Infrared Survey Explorer, they confirmed that the flare's energy was escaping equally in all directions. Second, they had to make sure it wasn't a supernova, the explosive death of a massive star. However, even the brightest supernova ever recorded couldn't match the luminosity of this event. That meant only one explanation fit the data. This was the brightest black hole flare ever detected, triggered by the tidal destruction of an exceptionally massive star. K.E. Sauvik Ford suggested that the reason such a huge star even existed near the black hole might be due to the unique environment of an Aegean. Inside the accretion disk, the constant supply of matter can cause nearby stars to grow larger than usual, as they absorb gas and dust from their surroundings. In other words, these massive stars might be born and fattened inside the swirling chaos of matter orbiting the black hole, only to eventually be destroyed by the same forces that created them. The discovery of this flare could be just the beginning. If one such massive tidal disruption event happened in this galaxy, there could be countless others happening across the cosmos, waiting to be discovered. The Zwicky Transient Facility continues to scan the sky for similar events, and the upcoming Vera C. Rubin Observatory will join the effort. Once it begins its full operations, it will be capable of detecting even more of these rare, powerful flares, giving scientists a clearer picture of how often they occur and what they can tell us about the life cycles of galaxies and their central black holes. As Matthew Graham summed it up perfectly, we never would have found this rare event in the first place if it weren't for ZTF. We've been observing the sky with ZTF for 7 years now, so when we see anything flare or change, we can see what it has done in the past and how it will evolve. It's a reminder of how much patience and persistence astronomy requires. The universe reveals its secrets slowly, sometimes over years, sometimes over billions of years. But with each new discovery, we gain a deeper understanding of how it works. This flare, born from destruction, is also an act of creation, giving scientists insight into the physics of black holes, the growth of stars in extreme environments, and the stretching of space and time itself. Somewhere in a galaxy far beyond our reach, a star is still being devoured, its light stretched, delayed, and scattered across the universe. And after 10 billion years, that light has finally reached us. We're watching cosmic history in slow motion, a dance of gravity and fire, and a reminder that even in the vast darkness of the cosmos, there are moments of extraordinary brilliance, fleeting, violent, and utterly beautiful. Out there in the silent reaches of space, the universe continues to surprise us, tearing stars apart, bending time, and defying imagination. If you enjoyed exploring this extraordinary cosmic event, make sure to subscribe to Spaceverse for more journeys into the mysteries of the universe. Until next time, keep looking up, because somewhere out there, the next great cosmic story is already unfolding.